Okay, so the division problem template that you have in front of you looks slightly different than mine because mine kind of pushes it. Mine turns it portrait layout, and your guys' is landscape. So I can't adjust that up here. But we're talking a lot about fractions, okay? You guys know a lot about division, but when we throw division and fractions together, your brains, it's harder to comprehend, okay? And anytime in math, I always say, let's focus on what we do know to help us figure out what? What we don't know. So you know a lot about division, right? Do you guys all agree? Okay? So in a division problem, there's 3 different parts. What are those 3 parts called? What are those 3 parts called in a division problem? Give me one, Addie.
Quotient.
Quotient. Quotient is a fancy name for what?
Answer.
The answer. In this problem right here, this top one is where we're going to write these words. Which of those boxes would be the quotient? Braylon? After the equal sign. So let's write quotient right here. Quotient. Okay. Kinley? A divisor. Which of those is the divisor?
The first one.
No.
Second one.
The second one. Divisor. And Aiden, what's the last one?
Dividend.
Dividend. Dividend. Okay, now next to yours, your equal sign is up here. So you're going to write the rest of the stuff out here to the side. I'm going to write it in this next row because that's where my equal sign is. Does that make sense? So you're writing it out to the right of quotient. If I had to set that up as a long division problem, what would go where? So out next to this equal sign, I want you to draw out your division bar. What would go where? Elise?
The quotient would go on the very top.
Okay, quotient would be up here at the top, yep. Quotient would be up there at the top. Carter?
The divisor go outside.
Divisor goes on the outside. So what's the only thing left, Addie?
Dividend.
The dividend goes on the inside. Okay, what if we wrote that division problem as a fraction? Well, I'm going to go ahead and write equals. We're going to leave quotient out of this one because we're just focusing on the fraction portion of it. What would go on top? What would go on bottom? We know they're called numerator and denominator, but I'm trying to get you to see the relationship between dividends, divisors, numerators, denominators. Addie? Yeah, the dividend is the numerator. The dividend will always go on top. So the number in the front of our division problem, if we write it out horizontally with a division sign, it always goes on top of our fraction. So then what's underneath it, Hutley? The divisor. Okay, and again, we call the top number of a fraction a numerator, the bottom a denominator. So we're kind of mixing skills here. We're mixing what we know about division and what we know about fractions. In math, what are the hardest problems? The hardest problems. Elise? Okay, possibly one with larger numbers. What else, Fisher? Aiden?
Ones that are not equal.
What do you mean?
Like, say you have like it is 80, and like 82 divided by 9.
Okay, but we can solve 82 divided by 9. It'll just have a remainder, or we could give the answer as a decimal or a fraction. What else? What about word problems? Jackson. What about word problems? What are your thoughts on those? You guys like word problems or dislike word problems? Dislike, okay? Because they make you think a little bit more than other ones. Word problems with fractions make our brain like explode, okay? So that's why we're going over this, because our problems today are word problems involving fractions, okay? So let's talk about division word problems, okay? I'm going to go down to the next set, and again, mine's all discombobulated here. How do we pick out a dividend in a word problem? How can we pick out a dividend in a word problem? What am I looking for in a word problem? And again, you got to think back. How can I pick out a dividend in a word problem? Kinley?
Like you see which one comes first.
It doesn't always come first. Doesn't always come first, and it's not always the biggest number. So I'm going to knock those two off real quick. It's not always the one that's given first in the word problem, and it's not always the biggest number. Fisher. It's not an odd number. It's a total of some sort. It's whatever in the problem you have that you're breaking into pieces or dividing up. Do you guys agree with that? Okay, so we're going to write that in this box. We're going to write that this first number is usually a total. It's a total, or what you have that is being divided or broken apart. Okay? It's some sort of total. And you have to think to yourself, in this word problem, what do I have, or what does Sally have, or Joey have, that's being broken into pieces or passed out, divided up? How do we pick out the divisor? So let's think of a division word problem with no fractions. Gabe, tell me something we have. What do we have? Give me an object. I have a bunch of squares in my pocket. How many squares do I have in my pocket, Gabe? 9, okay? I have 9 squares. I'll write this over on the whiteboard to give you an idea. I have 9 squares in my pocket. If it's a division problem, what do I have to be doing with those squares? Passing them out. Okay, I'm so nice, I'm passing out my 9 squares in my pocket. I'm passing out squares evenly to 3 people. What would the question be? If that's my problem, what would my question be? Augie?
None.
Nope, not my math problem. The word problem's not finished yet. I have the facts. I need a question. So I have 9 squares. I'm passing out squares evenly to 3 people. What question would it ask?
How many did each person get?
How many did each person get? Okay, and with these numbers, that seems very simple. If I would just put fractions in places of those numbers, our brain has a hard time comprehending it. That's why we're going back to the basics here. So the total in this problem, what do we have that is being divided or broken apart? 9 squares. Okay, how can I pick out my divisor? How can I pick out my divisor? Kinley?
How many things it has to be broken into?
So the number of groups. Are we breaking it into 3 equal groups? Yeah. So on this one, I'm going to write the number of groups So then what does my quotient represent in this problem?
How many squares each person got?
But how could it's the number of squares each person got, but how could I put that in a general thing.
How much each person got?
So the size of each group. The size of each group. So this one I had 9 total. I broke it into 3 groups, and there were 3 in each group when I finished. So the quotient in this one would be the size of each group we might have to add some more words to these when we get into some fraction ones, but I'm just trying to get you to think about these. Okay, now if it doesn't give that division problem, the dividend is always the total. What do you have that's being broken apart? If it is a division problem, it'll always give you some sort of total. If it's a multiplication problem, it'll be asking for a total. That's one way you can tell if it's divide or multiply. Let's go on down to the next set. Copy exactly what you had for dividend again, because we always pick that out first. It's the easy one. So it would be the total. What do you have that is being, I'm just going to write divided on this one. It's the same as above. Divided or broken apart. So who can change our 9 square problem to a different division problem where it still gives me 9 squares? How else could they have worded this and changed the question? So I have 9 squares. I'm passing out squares evenly. I'm going to put period there. How else could they have given me that same problem but in a different format? Augie?
I have 9 squares. I'm passing out the squares evenly. Each person gets 3 squares.
If each person gets 3 squares, what would my question be? How many people will get squares? What did we do to create that word problem? What was the difference between that first one and the second one? Because those are the only 2 ways they could give us a division word problem. Kinley? Yeah, so all they did was they flip-flopped these 2 squares. Okay, they always have to give us a total, and then they either have to tell us the number of groups or the size of the groups, and then we can find the missing piece. Okay, so what did we write here on this one? Number of groups. So on this one, let's write size of each group. Size of each group. I'm going to put / piece, because sometimes we're talking about pieces of things, especially when we get to fractions. And then, so what would go in our last box? Number of groups. So that's any division problem, whether it's a whole number division problem, fraction, decimal. When you are trying to pick out your dividend, you're looking for, what do I have? Some kind of total that is given that I'm breaking apart or breaking into groups, breaking into pieces. And then you have to decide, is it giving me the size of each piece or is it giving me the number of pieces? And we will always find the other one. Okay, keep that paper out, but set it aside. Open to Chapter 8, Lesson 1 in your book. I can tell you what page that is in just a second. Chapter 8, Lesson 1. See if it kicked me out while we were talking. Chapter 8, Lesson 1. Fraction as division. Fractions as division. Oh, it keeps going back to Lesson 8.
On page 551.
551. I think it kicked me out while we were talking.
I go back and I like
Sorry, it timed me out. Is it like an emergency or you think you can wait a few minutes? Okay, because this is brand new stuff today. So I'm going to start reading in Elisa's book while I'm waiting for this to load. So it says, a fraction is a number that names equal parts of a whole or parts of a set. A fraction represents division of the numerator by the denominator. So it's showing that 1/3 is equal to 1 divided by 3. I feel like we've already kind of established that. We're already aware that 1/3 is telling us to take 1 divided by 3. The numerator is the part. The denominator represents the whole. So if you get 1/3 of a pizza, that means you get 1 part out of how many total parts? 3. Okay? And we talk about our tests and assignments a lot. That means you got 1 question out of 3 questions correct. So this is where they give us a word problem, and it has all whole numbers in it. Our answers today will either be fractions or mixed numbers, most of them. You might occasionally get a whole number here and there, okay? So Dylan, Drake, and Jade are sharing 2 small pizzas equally after their lacrosse game. How much does each person get? So the first thing we have to pick out is our dividend. On our paper, what did we say we can look for to find the dividend? Elise?
What you have that is being divided.
Yeah, you're looking for some kind of total. What do we have in this problem that is being divided, passed out, or separated? Braylon?
2 small pizzas.
2 small pizzas. Do you guys all agree that we have 2 pizzas and that's what's being broken apart? Okay? So they took 2. I'm going to underline 2 small pizzas and above it write dividend, which means in our math problem it is written first. We took 2 small pizzas, and then for the second number, for our divisor, it either has to give us the size of the pizzas or how many groups we're splitting it into. What does this one give us? Wyatt? Where should you be focused instead of out the window? There we go. Hutley.
How much does each person get?
So that's the question. So that means that's our quotient.
Dylan, Drake, and
Yeah, this one makes us think a little bit. We need to know how many equal parts. Does it say it's splitting it into 3 equal parts? So how do we know that it's splitting it into 3 equal parts? Aiden?
the picture.
Not even the picture. We're not there yet. We're only in the words. Carter?
So it says Dylan, Drake.
Yeah, we have to read those words, okay? We have to read the words. Dylan, Drake, and Jade, which is 3 people. So that's where they came up with 2 divided by 3. 2 pizzas split between 3 people. Turn off your math brain, turn on your common sense brain. Will each person get a whole pizza? No. Will they get more than 1 whole pizza or less than 1 whole pizza? Less. What numbers are between 0? Because will they all get some pizza? What numbers are between 0 and 1? Fractions and or decimals. So that means they will get some pizza, they just won't get over 1 whole pizza. So here, this is math that you guys will like because there's not a whole lot of math involved. 2 divided by 3. You can write that as a fraction and that can be your answer. What is 2 divided by 3 written as a fraction, Gabe? 2/3. 2 divided by 3 is the same thing as 2/3. Does it make sense to say that Drake gets 2/3 of a pizza, Dylan gets 2/3 of a pizza, and Jade gets 2/3 of a pizza? Yeah, so we're done. That's all you have to do. Unless it's an improper fraction. What do you think we'd have to do to an improper fraction at this point? Carter? Make it a mixed number, and then we would be done. Okay, let's go ahead and go to, does this one ask, okay, right here. The amount of pizza each person gets is between what 2 whole numbers? And that's where we were just talking. If you have 2/3 of a pizza, Fisher, what 2 whole numbers does that fall between? So if you have 2/3 of a pizza, you have 2 whole pizzas and part of another one?
2 and 2.
Augie?
0 and 1.
0 and 1. Because does it have a whole number? What is the whole number to 2/3 if there's nothing there? 0. So we have more than no pizza, but we have less than one whole pizza. So it's between 0 and 1. Now let's turn to the next page. We're going to spend 2 days on this because this I got to kind of retrain your brain how you think about stuff. Maybe. Okay. I'm going to go to this guided practice. 2 bags of bird seed are used to fill 3 bird feeders. Let me click this. How much bird seed does each feeder use? Represent the situation using the model, then solve. We're going to ignore the model. What do we have? What do we have that's being broken apart, divided up, separated? Aubrey. You have 2 bags of birdseed. We have 2 bags of birdseed. So that's where, let's write this out here. We have 2 bags of birdseed. Then it either has to tell us how many groups we're separating it in or how much each group is getting. What else does it tell me? Huntley?
It says used to fill 3.
Yeah, we are dividing 2 bags into 3 equal parts. So 2 divided by 3. So our answer should be the size of each part or the size of each group without any math at all. What is 2 divided by 3 written as a fraction? Addie? 2/3. So I'm going to write it here, and then I'm just going to copy it up here. Is 2/3 a proper fraction or an improper fraction? Proper fraction. Can it be simplified at all? No, so we are done. So 2/3 is 2 divided by 3. So each feeder uses 2/3 of a bag of birdseed. That means you'll use 2/3 of a bag of birdseed for each feeder to fill them all up. The only other question I'll ask is, what 2 whole numbers does that answer fall between? 2/3. If you use 2/3 of a bag, what 2 whole numbers does that fall between, Elise?
1 and 0.
Do small to big.
0 to 1.
Between 0 and 1. Let's add that in. Between 0 and 1. So you'll need more than 0 bags for each feeder, but you will need less than 1 whole bag for each feeder. Let's go on to the next page. Okay. 4 families equally share something. And it went backwards. 4 families equally share 5 pies. How much pie will each family receive? So in this one, what do we have that's a total that's being broken up, divided, shared, passed out? Any of those division words, Lainey? You have 5 pies. So 5 is our what? 5 is our what? Our divisor, our dividend, or our quotient? Addie? It is our dividend. That's what's going to come first. So we're going to write this out to the side. We have 5 pies. We're breaking it into how many equal parts? Huntley?
4 families.
We're splitting those between 4 families. What is 5 divided by 4 doing? No math at all, just changing it to a fraction. Braylon?
5 over 4.
Okay, so let's say 5/4 equal, or 5 divided by 4 equals 5/4. We've been practicing these for a long time. Is that a good final answer for a fraction? Why not, Gabe? What's wrong with it? Because it's, what do we call that? You're right in your reasoning, but what do we call those? Carter, help him out. It's an improper fraction, so that's not a good final answer. It's not that it's wrong, it's just not the best answer. You want to say, ooh, each family gets 5/4 pies. Okay, it just doesn't sound right. So what can we do to make that answer better? Elise?
Make it 1 and turn it into a mixed.
Yeah, we can change it into a mixed number. So we put the 5 on underneath, 4 on the outside. How many times does 4 go into 5? 1. Now, if I wanted to give a decimal answer, I could add a decimal point in zeros. Do we want to give a decimal answer? So how do we write that as a mixed number? Fisher?
1 and 1/4.
Yeah, the remainder becomes our numerator. The denominator actually stays the same. So I'm going to write that over here. And now I'm going to fill these numbers over here. Each family receives 5/4 or 1 1/4 of a pie. So 5 divided by 4. Let's go ahead and write 5/4 and then 1 1/4 there. Does it make more sense to say each family gets 1 1/4 of a pie? Yeah, that means they each get one whole pie and then just kind of a piece of another one, okay? So this answer, 1 1/4, is between what two whole numbers? What two whole numbers is 1 1/4 fall between? Carter? 1 and 2, because they have more than one whole pie, but they have less than 2. So 1 1/4 comes between 1 and 2. Okay, let's look at number 3. Let me zoom in a little bit to make it bigger. 6 bags of soil are used to fill 5 flower pots. How much soil does each flower pot use? Between what two whole numbers does the answer lie? What do we have that's being passed out, divided, or broken into pieces? Clara? The bags of soil. And how many bags of soil do we have? 6. And you guys can visualize that. You can visualize some pots sitting on the ground and people splitting bags of soil into those pots, right? So we have 6 bags of soil split into how many equal parts, Lainey? 5. So our division problem is 6 divided by 5. Elia, what is 6 divided by 5 without doing any real math? Just changing that to a fraction. Nope, just changing it to a fraction. Mason, what do you think?
6 and 5.
6 over 5. Yeah, just 6 over 5. The dividend comes to the top, the divisor goes to the bottom. Now we know enough about fractions. Lexi, is that a good fraction to answer? 6/5. 6/5 bags of soil. Why not?
Because it's improper.
Yeah, it's an improper fraction. Bryson, how do I change that to a better answer?
Divided by 6.
Backwards. Say the top number first.
6 divided
We do 6 divided by 5. So we're going to set it up. 6 divided by 5. Emily, how many times does 5 go into 6? Just once, so that's 5. I have 1 left over. How do I write that as a mixed number? Aubrey? 1 1/5. Let's go over here and fill in all of our numbers. Each flower pot uses 6/5 or 1 1/5 bags of soil. So 6 divided by 5 equals, I'm going to write 6/5 or 1 1/5. So each pot uses 1 full bag of soil and 1/5 more. The answer is between what two whole numbers? Elise? 1 and 2, because you can look at the whole number there and it's always just the next one. So if it's 1 and something, it'd be between 1 and 2. Because you have 1 full bag and a little bit extra, but you don't have 2 full bags. Okay, let's go on to the next one. Number 4. 40 yards of fabric are used to make 9 school banners. How many yards of fabric does each banner use? Between what two whole numbers does the answer lie? What is our total? What do we have that we are breaking apart, separating, dividing up? Gabe? You and your squares. Square is just a label up there. Aubrey?
40.
We have 40 yards of fabric. We have 40 yards of fabric that we are cutting up to make banners. So we start with 40. That is our dividend. We have 40 yards of fabric. How many pieces are we breaking that into, Emma Kay? 9. We're breaking it into 9 equal parts. What is 40 divided by 9 with no math involved, Kinley? 40 ninths. 40 ninths. Now, as a fraction, is that a good fraction answer? Hutley, what do I do to it?
You have to put 40 inside the box and 9 outside.
Yeah, I have to put 40 inside the box, 9 on the outside. Now we just do some long division. Augie, how many times does 9 go into 40?
4 times.
4 times. And what is 4 times 9?
36.
36. So we have a remainder of 4. How do I write that as a mixed number, Wyatt?
4
Good job. 4 and 4 ninths. So that means if I have 40 yards and I divide it into 9 equal parts, each part will be 4 and 4 ninths yards of fabric. That's if I have no leftovers. So 40 divided by 9. It's very repetitive here. It has me write the same thing over and over and over. Now that answer, 4 and 4 ninths, falls between what two whole numbers, Addie? 4 and 5. Good job. Because you have more than 4 yards, but you have less than 5 yards for each banner. Okay, go ahead and turn the page. I might be able to turn the page. Okay, let's go up to number 5. Is this the right one for you guys? Desmond or... I don't know why it keeps doing that. Okay, so DeMont used 4 gallons of gasoline in 3 days driving to work. Each day he used the same amount of gasoline. How many gallons of gasoline did he use each day? What are we talking about that's being divided, broken apart, or separated, Lainey?
4 gallons.
Yeah, we have 4 gallons of gas that we're working with. So out to the side, let's do the same thing. We're starting with 4. How many equal parts are we breaking it into, Bryson? 3, because we're breaking that into 3 equal days. Fisher, what is 4 divided by 3 with no math at all? 4/3, good job. And sometimes when you do that, you're like, ooh, I'm done. On this one, are we done?
No.
Nope. Addie J, what do I need to do?
Make it a mixed number.
Yeah, how do we make it a mixed number? Nope, 4 on the inside. There we go. Okay, how many times does 3 go into 4, Addie? Once. So that's 3. And what would my mixed number be, Addie? 1 and 1/3. So how many gallons of gasoline did he use each day? What would my answer be? Hutley?
He used 1 and 1/3 of gas each day.
So we need a label in there. He used 1 and 1/3 of gas. What's our label for gas? Gallons of gas. Why is it plural? Because you use more than 1. So it really, this is where it gets tricky. If he only used 1/3, you wouldn't say he used 1/3 gallons. What would you say? You could actually say it 2 different ways.
1/3 of a gallon.
You could say 1/3 of a gallon, or you could just say 1/3 gallon. It sounds a little funny, but that's also appropriate. So I'm just going to write 1 1/3 gallons of gas. And then what other question did it ask us on all of the other ones that I want us to answer on these ones, just because it's kind of a harder skill for some people. Carter? Yeah, what is that between 1 and 1/3? Lainey?
1 and 2.
Yeah, so I'm going to write out here it's between 1 and 2. I want you guys to try number 6 on your own real quick. Number 6. Do all of that same thing. Write the horizontal division problem, change it to a fraction, then decide if you're done or if you need to go further. Lexi, in this one, what do we have that's being divided, separated, broken into pieces, broken into parts? So, are you chopping up people? Because that's people. That's 10. And can we divide people into groups? Yes. But is that what we're doing here? What are we separating? 2 gallons of whatever we have. Why do we not like putting that 2 first? Hutley? Because it's smaller, but we just know, can our answer be a fraction? Yeah, so don't look for the bigger number. That's why I shot that down at the very beginning. We have 2 gallons of punch to be divided equally by 10 people. Is that a realistic problem? A gallon are those 2 big jugs. Could 10 people share 2 gallons of? And now, if you did this backwards, you're saying each person gets 5 gallons of lemonade. Why does that not make sense? Aiden?
Because nobody could actually drink.
Okay, no one could drink 5 gallons of lemonade at a short little party. Okay, why else? Aubrey? There's only 2 gallons. Okay, so sometimes if you turn off your math brain, turn on your common sense brain and think about some of these, it's like, okay, that answer doesn't make sense. They can't each have 5 gallons of lemonade. So this one is 2 divided by 10. Carter, what is 2 divided by 10 with no math at all? 2/10. Is that a proper fraction or an improper fraction? It's a proper fraction, so we're on the right track. Do we have to do long division to divide it out? But what can we do to it? Hutley?
We can divide it by 2.
We can reduce it. Yeah, we can reduce it by 2 to create an equivalent fraction that's just a little bit smaller. So I'm going to do divide by 2. Divide by 2. What's 2 divided by 2? 1. What's 10 divided by 2? 5. So what is my answer? Jackson?
1/5.
Can you add to that?
1/5 gallons.
1/5 gallon. Why is it singular?
Because it's 1 out of 5. Out of the 5.
Nope, and I think he might have missed this conversation. Why is that singular? Carter?
Because it's not more than 1.
It's less than 1, okay? You could say 1/5 gallon, or you could say 1/5 of a gallon. Both of those are properly for each person. And then again, it's between what 2 whole numbers? 1/5 of a gallon. Aubrey?
0 and 1.
It's between 0 and 1, because you get more than 0 gallons of lemonade, but you get less than 1 whole gallon of lemonade. Okay, hopefully these are getting easier. And again, when you get to some of them tonight, your brain's just gonna, your brain will struggle with these a little bit, okay? So do your best on tonight's homework. What do you think we'll do tomorrow? Go over it, and then we're gonna do some more. So tonight's homework are the 2 homework pages, so page 555 and 556. On page 556, up at the top, right between question marks. So at the top of page 556, I just want you to write between question mark at the top. Why do you think I'm writing that at the top of that piece of that page, Braylon? Yeah, on any of them that doesn't ask which two numbers it falls between, I want you to kind of write it out to the side. It's between 5 and 6, or it's between 1 and 2. Okay, because tomorrow's worksheet will ask that on every single problem. Okay, questions on your homework? It's page 555 and 556. I want you to try them all. Which ones are probably going to be the hard ones? The brain builders. Yep. Okay, you guys can go ahead and go. I'll see you later on.